Imagine Beyond 5G sponsored via Open Call 1 Project ALMA at Norwegian Facility. Project ALMA is basically 5G enabled AI gloves that are used in the production environment for the production workers in order to assemble the machine.
Our product is the smart glove with artificial intelligence, and it used Wi-Fi for communication, which has shown to be prone to delays, impairing user experience. In this project, we have replaced it by 5G standalone versions, so for private networks, that has shown much better result. We have reduced jitter considerably, and now AI data detection is working much faster, improving the user experience.
From ABB standpoint, we see many different use cases of such a technology. From workers working on the factory floor to the workers working off-site, remote locations, and even the employees working on regular office environment. So this could be utilized for things such as tracking the efficiency of the workers for the repetitive tasks they are currently conducting as part of their regular job, or for things related to HSE, and even going for training.
Telenor provides secured indoor 5G private networks that could provide good performance KPIs as compared to the alternatives. For example, having a latency and jitter that is required for Industry 4.0 applications.
So overall, very good technology, and we'll work together to see if there are potential use cases which we can demonstrate as part of this Imagine Beyond 5G project.
Imagine Beyond 5G projects builds a large-scale 5G facility to support the trials and experimentations of core technologies and architecture as a means to facilitate the innovative vertical services and applications. One key component or mechanism to enable future Beyond 5G vertical applications is Open Call. LEOSED is one of the first open call projects funded by the Imagine Beyond 5G project to trial and validate their vertical applications using the Norway facility site.
So LEOSED is actually quite important to the healthcare industry because it provides a fully contactless method of following the patient's vitals, such as heart pulse and blood oxygen saturation. Both parameters can be used to allow the healthcare professional to follow the general wellness of the patient without having to touch them, which is incredibly useful in cases such as the coronavirus pandemic. Within the project, we developed two platforms which we call clients and one platform which we call the server. The server is integrated within the Telenor Research core platform as an edge server, while our clients are here with us, and we use them to test the health measurement of our vitals. By using this client, we simply have a refined graphical user interface, which we click to start the experiment, and then the entirety of our data goes to our 5G network, and we get the results back of our general wellness. The system consists of multiple parts. The main part of the system is our camera. The camera detects the color changes of a person's skin, which help us extract the measurement of the vitals. The rest consists of the touchscreen to interact with the graphical user interface, the lights to better illuminate the patient's face, a 5G modem to work with the current Telenor network implementation, and a laptop that controls all the elements here showed.
Our solution takes advantage of a Beyond 5G wireless network in order to connect multiple clients and able to measure heartbeat and oxygen level within a second, including computation, network processing, and receiving back the results.
To support Imagine Beyond 5G use cases, we have also extended our 5G network and deployed an indoor 5G radio site that meets the performance KPIs of these Beyond 5G use cases.
Final goal of the project is to showcase the feasibility of monitoring the person's vitals in a fully contactless way. The product can be simplified to one camera device that is to be fully integrated within the Beyond 5G network in a healthcare facility. During the summer seasons, when it's very dry, it's challenging to do forest operations. And this is because that the forest machines can start fires. Having a solution that can detect fires early on is very important.
AI for Forestry provides a forest monitoring and surveillance framework, which utilizes mix of technologies like 5G, drones, ground sensors, and edge computing. The edge computing is used for image and video processing using AI and machine learning models. In a holistic view, the drones flying over the forest send videos and images over 5G, which are processed on the edge and provides real-time forest health parameters, for example, vegetation index.
The live captures from the drone are also used for early fire detection, where in case of detection, a text message is sent to emergency personnel with the fire location. Ground sensors connected over 5G are also deployed across the forest to measure temperature, pressure, humidity, displayed real-time on the web profile.
.5G Neptune is funded by Open Call number 1 of Imagine-B5G. The name of the project stands for 5G and Beyond Network Extensions towards Public Network Integrated Non-Public Networks, and the project is carried out by Hewlett-Packard Enterprise over the Norwegian Facility of Imagine-B5G, operated and owned by Telenor. The project targets the extension of the facility towards non-public networks. In particular, we will install an HPE IP multimedia subsystem over the network on wheels of the facility. Then we will install an HPE 5G core network at Telenor's premises for NPN experimentation, and then we will interconnect such 5G core with a network on wheels into a single system that we call a public network integrated network on wheels. The HPE 5G core network is made of fully virtualized 5G core network functions, including the IMS. It exposes 3GPP standard interfaces, and it is suitable for distributed deployments where different network functions are instantiated in geographically different sites. Further, the core supports network slicing and features like DNN access control, control over quality of service parameters, and other security features. The project's architecture is depicted here. It is made of two sites, Telenor's central site and the network on wheels. The two are interconnected by a wireless backhaul, and the two sites are part of a single main infrastructure. This means that users on both sites can access any of the two data networks whenever allowed, as long as the backhaul is operational. Further though, when backhaul is not available for any reason, the two sites need to be fully independent, and in particular, the network on wheels needs to allow connectivity services and guarantee connectivity services to its users and full access to the local data network. The scenarios we are targeting are the following. So first of all, we are putting ourselves in the perspective of a mobile network operator that offers private services over dedicated resources of a public infrastructure. Then we want to demonstrate the operation of an autonomous network on wheels, which acts as a moving standalone 5G network, operational also with unavailable backhaul. Further, we want to show how this can be integrated with the main site, with the public 5G network, and how users can have seamless access to the whole network when backhaul is available. Further, we will implement DNN access restriction to give different access rights to different users and authorize only certain users to utilize the resources of the local data network. These scenarios fit the use cases of different vertical sectors, for instance the media sector, smart forestry and agriculture, e-health, and PPDR, public protection and disaster relief. In particular, initial trials for the PPDR sectors are already being carried out with the help of the Norwegian Defense Materiel Agency, who is providing actual users and actual devices for PPDR trialing. The results of this experimentation will be made public by the end of the project. Thanks for watching.